Okay, good afternoon. Sorry for that. My name is Janet Beva. I'm going to present a presentation on infrastructure resilience on expansive soil. There is a case study in Meru County of community challenges and solutions in Kenya. My supervisors are Dr. Joseph Muiti, Dr. George Mungai, and Dr. Ratumo Toel. Welcome. According to the World Bank report 2022, the world's population is at 8.1 billion, with Africa having 1.5 billion and Kenya 56 billion. This rapid population growth escalates for infrastructure demand. So let's look at what infrastructure is. Infrastructure refers to the basic physical and organizational structures needed for a society or business to function, encompassing both physical assets and systems that supports them. My study is going to dwell on the infrastructures, specifically roads, bridges, and buildings. And regardless of having high demand on these infrastructures, we are still experiencing infrastructure damages. Like, for example, this image here displayed shows a collapsed building and also a broken road. And we usually incur a lot of expenses to repair such collapses of buildings. And this study focuses on what could be the major causes of this. And some of the main causes which we know might be poor designing or even poor workmanship, among others. But all we know is that all these infrastructures are laid on soils. So even the soil stability is very key in the infrastructure durability. And this takes us to what expansive soils are. These are a group of soils which, once they absorb water, they swell, and they swell drastically and also shrink. And this swelling and shrinking of this type of soils really affects the infrastructure durability and leads to some cracking, which later can cause infrastructure damage. And this therefore calls for soil stabilization before all these infrastructures are laid on such soils. Soil stabilization is the process of improving the soil's geotechnical properties, and we have various types of stabilization, where we have chemical stabilization, which involves addition of chemicals to the soil, and mechanical stabilization involves methods like removing the soil which is unstable and replacing it with a stable soil. And that method is somehow considered to be so much expensive to remove the entire soil and replace with another one. The problem statement of this study is that the rapid population growth leads to infrastructure demand and also pressure in the infrastructure. And we all know that these infrastructures are laid on soils. So once they are laid on expansive soils, this could be one of the cause of infrastructure damage. Justification: sustainable infrastructure relies on understanding geotechnical risks and community involvement, and this is in line in SDG 11, which supports building cities that are inclusive, safe, and resilient, and also in line with SDG 9, which promotes resilient infrastructure, sustainable construction, community-driven solution. The research objectives were to investigate community challenges and propose solutions for improving infrastructure resilience on expansive soils in Kenya. And the specific objectives being to identify the main cause of the infrastructure as perceived by the local residents and assess the community awareness of soil stabilization, then propose community-driven technical recommendation for the improving infrastructure durability on expansive soil. The methodology for the study was that structured questionnaires were given to various respondents in the community, and The data collected was analyzed using Excel, and therefore it was interpreted as follows. This is some of the data which we were able to collect. The first one was to check the perception of the infrastructure quality in the community, and we could see that highest percentage of the community members, that is 53.3%, said that the infrastructure was fairly perceived in their community, with 10% saying it's very poor and no percentage which perceived that the infrastructure was good or very good. We also have the community experience with building collapses. Around 78% of the community members perceived that they've encountered or they've heard about building collapses across the country. And also, the other parameter which was looked at was the group which is most affected by poor infrastructure. Then a percentage of the community members said that everyone is equally affected by poor infrastructure. Then the other parameter was the cause of infrastructure damage. We had several causes which we were able to collect. That is agent wear of the infrastructure, overloading by vehicle users, lack of maintenance and repairs, then inadequate design or engineering designs, then poor quality of construction material, with lack of maintenance and repairs being the highest percentage dominating in that. Then the other parameter was the community views on the role of soil stabilization for the infrastructure, and 81.3% of the respondents said that soil stabilization is very important to infrastructure because it enhances the durability or the strength of the infrastructure. The conclusion of the study: poor infrastructure is a major challenge, and we're able to conclude these are some of the causes which we were able to get from the community respondents: weak soils, substandard materials, poor designs and lack of maintenance, and also the damages caused by this leads to safety risks and economic losses, and therefore soil stabilization is key because it will improve soil strength and load-bearing strength. Recommendations is that use of appropriate soil stabilizers to improve soil strength and durability, and also recommend that we ensure proper testing of soil properties before designing and construction to know whether the soils we are laying our foundation on are expansive or not. Then we monitor the stabilized soils regularly and maintain treated surfaces to prevent failure and control load to avoid overstressing on the stabilized soils, especially in weak subgrades. And lastly, strengthen policies which promote soil stabilization infrastructure development. Thank you.
Thank you, Janet, for the wonderful presentation. I'm sure the audience has some questions which they will ask after we have come to the end. So you can take your seat. The next presenter is Joseph Mwangi. After that, we go to Dismas Kitaria, if you're in the house. Then we go to Patrick Mwenda, in that order. And we are timing now. If you don't finish by 10 minutes, unfortunately, we will have to stop. We intend to finish by 3:30. We are required at this closing ceremony, and all of us, we don't want to be the last group to rush there. So again, I'm reminded those who are in the line to present, kindly send your slides right now so that we take minimum shortest time in setting up. You can go and see him privately and arrange to send. So you start. It is 3:13.
Okay, good afternoon. I'm Joseph Mwangi Kaigai. My supervisors are Dr. Joseph Mwiti Marango and Dr. Julius Ratumotoer. I'm dealing with utilization of masonry cement in Kenya's construction industry, the perception, barriers, and opportunities. Much has been said about the population of the global population, the projection, and the need for construction materials or the need for infrastructure. And by 2050, the projection of the world or global is supposed to be 9.6, with about 6.5 billion living in urban areas and about 2.9 billion living in informal sector. That situation is still duplicated in Africa, where by 2050, about 2.5 billion people will be living in, the population will be around 2.5, and around 1.5 will be in urban, and in informal sector will be about 1 billion people. Closer home here in Kenya, the same situation, such that 39 million people by 2050 will be living in informal sector. This shows that there has been, since the inauguration of Vision 2030 in 2008, it predicted that there will be 250,000 units being supplied per year, but only about 50,000 units are supplied every year. And if you calculate, you find that the balance is around 2 million to 3 million by 2023. This shows that there is need for infrastructure, there is need for construction, and there is need for construction materials, and among them is cement, and cement being the most used. About 4.1 billion metric tons of cement is used every year. And we have several types of cement, and they are normally categorized according to composition, performance, characteristic, and intended application. I don't intend to read all of them because we have ordinary Portland cement, which is the most used and the most known, and actually people think cement is ordinary Portland cement, but we have several other types of cement, including PPC, Portland slag cement, and so on. This is where masonry cements come in as one of the cement due to its application. And masonry cement, or rather in a building, the percentage of usage according to strength is around 50 to 30% is masonry work. That is masonry work. Around 50 to 60% is concrete, slab, and foundation. That requires high strength. Around 5 to 10% is plastering. 5 to 10% is roofing. 5 to 10% is the other part of finishing, and that is tiles and so on. And if you calculate, you realize that the percentage of a building that requires low strength cement is approximately 50%, 40 to 50%. And that brings us to masonry cement, and we say masonry cement is a highly substituted type of cement where clinker is approximately 40%. The other part is substituted normally by natural pozzolana that does not undergo the process of clinkerization, and it has several advantages. One of them is improved water retention, walkability, enhanced adhesion, and cost effectiveness. And it is normally used in a part of building for plastering, screeding, decorating, coating, rendering, repair work, and brick and block laying. Now, in my problem statement, you realize that masonry cement has significant application and advantages, but unfortunately there is still minimal use, and many people rely so much on ordinary Portland cement, which has high strength, unnecessarily high strength, and this leads to inefficiencies, compromised quality, and material waste and unnecessary cost. My research want to identify the gaps leading to this underutilization. What are the barriers? What are the perceptions? What are the stakeholders concerned? And by that, we'll be able to find that will improve the efficiency in construction and break through in the stagnated masonry cement market, and therefore develop strategies to bridge the gap. The general objectives are to assess the utilization of masonry cement, with specific objectives being to assess the level of awareness and current utilization of masonry cement, identify key barriers, evaluate stakeholder-specific perceptions and their roles, and propose practical stakeholder-informed strategic and policy recommendations. The methodology includes a structured questionnaire that was used through Google Forms and also through hard copies. The sampling was purposive and due to different stakeholders like client, designers, contractors, and so on. And the analysis was descriptive statistics, where both qualitative and quantitative data, we got both qualitative and quantitative data. Some of the results that we are able to find, the respondents were as shown in the pie chart below, and the majority, you realize, were homeowners and home users. And that is very important, because the construction industry is driven by rather uneducated or unskilled people. They are the one who buy cement. They are the one who dictate to the constructors what to be used, but the other percentage, the construction workers, still lies on the homeowners and home users, construction students. That is some of the respondents that I got. I don't want to go to the details because of time. And you realize that out of the 38 respondents that I have, that 75% said they have never used masonry cement. And you wonder what they used to finish their construction. And 25% said that they have used masonry cement. And one of the things that we realize is that could be 75% they have used, but they don't know. And the other, we checked at the satisfaction level for those that say that they have used, and the satisfaction level ranging in a Likert scale of between 0 to 5, about 12 out of the whole population said they were satisfied, with around 6 people said that they were not satisfied. Some of the, we also looked at the cost of cement in the market, and you realize that the 32.5 megapascals is ranging between 790 to 880. 22.5 megapascals, where masonry cement ranges, is between 630 to 700 Kenya shillings, and that shows that though it should be lower, people still don't know that it is cheap in the market, but we realize that it is highly priced when we consider the cost of the raw materials used to manufacture that. The reason for those that were using masonry cement, some of the reasons that they were giving, the biggest percent, about 53%, said it is because of better workability. About 13% said it has quick setting, which is not the truth. And the other one, about 25%, said it has cost effectiveness, and improved adhesion had 9%. Now, in my conclusion, we realize that many users lack awareness of masonry cement, benefit, and correct application method. There is high cost perception discouraging adoption despite long-term value in masonry cement, and there is outdated standard, and sometimes no standard at all, mandating the industry to use masonry cement in specific areas, and then there is low demand due to disjointed information in the cement industry where people don't know that masonry cement exists. And that's the end of my presentation. Thank you so much.
Thank you. Let's give him a hand clap. Next presenter is
I'm presenting a research on a stative firewall packet analysis model for filtering session physician attack. My co-authors are Professor Amos Omamo and Dr. Miri Mwandulo. That is the presentation outline, areas that I will cover. As we all know that the internet has made the world to become a global village, whereby communication devices also have come up in large number, and as communication devices have increased, the network security has become a problem, so there is a need to enforce network security. So a firewall is one of the tools that enables us to improve the security of our network, whereby a firewall monitors the incoming and outgoing traffic to permit the data through the network or to block, depending on the security rules. There are several types of firewalls, and particularly this research has factored one of the type of the firewall, the stative firewall. And this firewall works in a way that to enforce network security, it imbues up packet filters by keeping records of every record or information that passes through the network, such that when another type of information comes through the network, it compares it with the information that is already stored in an area called state table. So if that information is similar to the information that is being stored in the state table, a packet or the information can be allowed to pass through. If then it does not rhyme or it is not similar, that information is blocked. Session physician is one of the network attack. And these attacks operate in such a way that it targets the internet users, whereby it captures the session IDs. When you enter into the network, when you are using the internet, as a user, you are assigned a unique identifier known as a session IDs, and session physician tries to get the range of that section IDs, or to capture that section ID so that it can maneuver and interfere with the data of a legitimate user. As I said earlier, there are several types of firewalls, but this research has factored the stative firewall, and there are several stative firewall models that have come up, and they deal with the different types of threat. So the research is targeting session physician threat that is not addressed in other existing stative firewall models. So the main objective of this study is to develop stateful file packet analysis model for filtering session physician, and specific objectives are to design a stateful file model tailored or specifically targeting session physician threat, and then validate the accuracy of the designed model. The literature review was conducted in those developed stateful file models, and the research gap was identified such that most of the standards that are, or most of the models, stateful file models that have already been developed, they does not consider well parameters, and still some standards do not consider the accuracy level achieved when filtering threats, and other standards do not analyze the entire packet. And lastly, those standards cannot filter session physician threat. When conducting the research, dataset was obtained online. The data was, it undergone the process of pre-processing, whereby numerical features such as source and destination address was extracted, and event columns was converted into binary target variables, whereby session physician attack was labeled as 1, and the normal data or data that is free from threat was labeled as 0. That table shows the selection features that were analyzed, the session IDs, event type, event timestamp, and then the experimental setup was carried on, whereby initial data undergone the process of pre-processing, and feature extractions were done so that the required parameters to be used in the model was extracted. Then the training data was carried on, whereby the model used the ingredient booster classifier. This is an algorithm that split data into different parts. And then the testing data was used to evaluate the efficiency of the ingredient booster, and then there was optimized, the result was optimized. The libraries that were utilized, we have Python. The Python was used to develop the model, and other libraries or software that were used are listed below. That is the design of the model, whereby the data that was collected was split into 3 parts: the training data, testing data, and data for the validation to validate the model. The graphical user interface was developed. After taking the model through the, simulation, it was noted that validation of accuracy in filtering session physician attack, the model could achieve an overall of 98.5%, because it was tested through several scenarios. For example, the blue part represent referrer handler manipulation. That is a network threat type. 98%, that is the, is it purple or? Yes, it represents the cross-site scripting. The red part represents session hijacking. Later on, there was a comparison of developed model with other models, whereby the developed model could achieve 98.5%. Recommendations are that the model to be adopted in network security, and Still, regular testing and simulations can be carried out to improve the model. And in the future, the researcher recommended that the standard to be extended so that model can, specific models can be developed targeting specific session physician attack. Thank you.
Okay, thank you. The next presenter is Patrick. Take to the stand quickly, please. We are running out of time. We are required on the other side. My supervisors, I want to appreciate them, Dr. Amos Chege, assisted by Professor Amos Omamo. My proposal is on real-time detection of fraud in SACCOs. And this research focuses on real-time financial fraud detection within SACCOs in Meru County, Kenya, leveraging AI and machine learning for enhanced accuracy. We propose an hybrid machine learning model combining both the supervised and unsupervised techniques. The supervised techniques, we talk this the decision trees, random forest, and the supervised is K-means clustering technique. Our research is inspired by high accuracy models by Halley and Agag. That is on their research they published. And our model targets 94% accuracy with a 0.92 F1 score, 2% false positive, tailored for SACCO constraints. Our model will be integrated with SACCO core systems via REST and API interfaces, ensuring in-time transaction monitoring. The growing threat of SACCOs fraud. Financial fraud poses a significant threat to over 5 million SACCO members in Kenya, with an estimated loss of 108 million in 2023, as per the SASLA report that was released. And this necessitates advanced real-time cyber security monitoring. Traditional methods like manual audits and rule-based systems are slow and prone to high false positives, failing to effectively identify fraudulent transactions. Yes, we understand there are a lot of security measures that have been implemented, but we have a challenge of the changing fraud threat. It's changing, and at SACCOs, there need to be real-time monitoring of the transaction. Our research proposes a AI-driven fraud detection model for SACCOs, combining both supervised and unsupervised learning to overcome these limitations. And to address the unique SACCO constraints, because most of the models that have been done or implemented mostly favors the bigger banks and also the bigger fintech companies because of the kind of investments that are there. Unlike for the SACCOs, which I know most of us, they belong in a SACCO, and some of these challenges you've come across.
And while machine learning systems are common in large banks, as I've mentioned, existing tools aren't optimized for SACCOs operational constraints, including limited infrastructure, sparse data sets, and low automation. Our solution addresses these specific challenges. One, data imbalance resolution. We tackle imbalanced data sets where fraud cases are scarce using undersampling for non-fraud cases and oversampling for fraud cases. We have a SMOT for synthetic data. That is synthetic minority oversampling technique, which we intend to use to generate synthetic fraud cases to balance the data set effectively. This ensures that we retain the originality of our data sets. Outlier detection. When undersampling falls short outlier detection, techniques will be applied, define the oversampled data set, ensuring robust fraud detection. Our key objectives of the research: one, that is the model evaluation, the AI and machine learning model evaluation, to evaluate the capability of AI models in identifying financial fraud, specifically within SACCO environment. Model comparison, to compare the performance of proposed machine learning models against traditional rule-based systems in fraud detection. The third key objective is data imbalance handling. We intend to develop and implement effective techniques through SMOT, as we had addressed earlier, for addressing data imbalance in SACCO financial data assets. In terms of deployment, we intend to implement a real-time, scalable, and fraud detection model within SACCO IT systems in Meru County. Part of our literature review, we trying to understand the fraud, understand fraud and detection within the SACCOs, and we defined what is fraud as defined by the Association of Certified Fraud Examiners. Fraud involves deceiving SACCO members to illicit gain money or assets from their accounts. And you have seen the kind of money, as per the SACCO reports, that has been lost, and which currently also it's happening in some of our SACCOs. Fraud detection, this encompasses measures to prevent the acquisition of money or sensitive assets through false pretense. In the SACCO sector, it's crucial for safeguarding member funds and confidential information. That is as per the Association of Certified Fraud Examiners. Next, we have the evolving fraud detection approaches as part of literature review. We have the rule-based. These rely on static, predefined rules, and often leading to high false positive and limited adaptability to new patterns. And you realize some of the audit tools that have been presented, most of them are rule-based, and we need dynamic. We need tools that are able to learn the changing, the fraud threat. Machine learning algorithms, machine learning models learn patterns directly from data, offering greater adaptability and precision in identifying fraud. We have a hybrid system. Our proposed approach combines the strength of supervised learning, decision trees, random forest, and unsupervised learning. That is the key means for comprehensive fraud detection. Our proposed algorithm, we intend to use decision trees, and one of the advantage of decision trees is because of its interpretable, lightweight, and but prone to overfitting, which can limit generalization with evolving transaction data. Overfitting, which is a challenge of decision trees, will be addressed by the random forest. Where random forest is highly accurate and robust, this algorithm mitigates overfitting by aggregating multiple decision trees, enhancing predictive power. That is as Bokati 2024. That's the research that was done by that researcher. We have our K-means clustering. K-means clustering, it's effective for detecting anomalies in unlabeled data, which is a challenge in SACCOs, basically because of how some of these SACCOs have been formed and the challenges that SACCOs, unlike banks, the SACCOs are facing. That is particularly useful for SACCOs with the extensive unlabeled historical transaction data. We have other algorithms like logistic regression and neural networks. And neural networks commands very high computational power, and also the data. Our core algorithm selection, we agreed on 3 decision trees we've mentioned.
You have 1 minute.
Yes, random forest and K-means. We have related work and our unique contribution, while fraud detection in financial institutions is widely explored in various machine learning algorithms. Most existing models are designed for commercial banks and large fintech firms. These institutions typically have access to abundant data and computational resources, which are often not available to the circles we are in. Our research uniquely focuses on developing a specialized model that's affordable for the circles, that addresses the specific operational constraints, data limitation, and infrastructure realities of circles in Kenya, ensuring practical and sustainable implementation. Thank you.
Okay. Thank you for that. We wish you all the best in that particular research. Dismas, or is it Dismas? Oh, Dominic. Yeah, is the last. Take, if possible, 5 minutes. Avoid some slides. Go to the coding and show us, yeah. The rest we can read on the paper. I think the papers are going to be published and we can follow up with any clarifications. Thank you.
Ladies and gentlemen, good afternoon. My name is Dominic Gikunda from the School of Engineering and Architecture, taking Bachelor of Technology in Electrical and Electronics Engineering. And this was my final year project in partnership with my brother Daniel Munene, and under the supervision of our lecturers Fiona Atieno, Dr. Lucas Mogaka, and Job Kerosi. The title for the project was the design, fabrication and testing of a smart solar-powered cowshed. Why cowshed? Agriculture is a sector that we cannot ignore. It's very key in very many economies in East Africa, and particularly here in Kenya. And with the current trend, we cannot ignore the fact that everywhere we are trying to go green and adopting the use of renewable energy, and that's why we based our project with it being solar powered. So for small-scale dairy farmers farming, sustaining rural livelihood in Kenya but face energy, labor, and climate changes challenges that limit its productivity and sustainability. Manual livestock management hinders efficiency and animal welfare, but for our system, a smart solar-powered farm offers a sustainable solution against labor and climate challenges. For our system, we used Arduino and sensors, enabling the farmers to boost productivity and cut labor through smart control system. This project presents a holistic design and testing of a small cowshed prototype that automates various activities that take place in the livestock keeping setup, which include feeding, watering, lighting, and the temperature in the environment. That's where the temperature regulation comes in, and the cleaning for the dung removal. So the system is powered by an off-grid solar panel unit, and it's tailored for the context of Kenya's small-scale farmers who typically manage between 3 to 10 cows. Our main objective was to promote sustainable livestock farming by developing a renewable energy, power and cowshed solution that reduce dependence on manual labor work and green electricity. For the specific objective, we intended to automate the feeding, watering, temperature control, lighting, and cleaning processes, improving overall farming efficiency. For the methodology, we split the project into various subsystems. For the feeding, watering, lighting, temperature control, water management, and we end the sector for the control and logic. For the feeding, we end the ultrasonic sensors, which detect the presence of the fins in the animal compartment, and the stepper motor, which regulates the opening. I will display in the slides which contains the pictures of the prototype. The system architecture, the system is solar powered. That is the solar system, solar power, charge controller, battery, regulator IC, temperature sensors for the system controlling the temperature control. LDL is a sensor. This is a sensor for the lighting. This controls the lighting. Ultrasonic sensor used for the feeding, and water level sensor. I will just display in the prototype. Okay, so this is what we have developed. It's a prototype to display what can be applied in the outside setup. This one here displays the feeding. This is a feeding kind of a storage. This one here is a servo motor, which is controlled by the Arduino, ultrasonic sensors, which detect the presence of fins in the feeding compartment. When it detects, it sends it to the, it's controlled by the Arduino and controls the opening of the servo motors. Inside here we have the vibration motors, which causes vibration and allows flow of the fins to the compartment. And as you can see, there is a fan that is for the temperature control. This was the control part for the systems, which involve the use of Arduino and the sensors. This one is for the water level sensing. That one above there, the black one is the water level sensor, and this is a solenoid valve that controls the inflow of the water to the watering compartment. This one here is for the automated feeding. In our system, we designed that, which is not a new thing, even in the current cautions, the flows are designed starting at an angle. So for ours, we implemented a conveyor belt at the end of the slanting edge of the floor to carry the waste to the storage area or to the biogas where the animal waste is placed. So in conclusion, for our system, the feeding system performance, it was tested and it worked as intended. Same case to the watering system accuracy, the float-based sensor and solenoid valve combination maintained water level within a 3 centimeter variance band. During peak operation, the system activated at an average of 5 times daily. The light control efficiency, the dial-based light system responded to illumination change, grow to 50 lux cooling systems also responded to ambient temperature, monitoring using the temperature sensor. In conclusion, the smart solar-powered Gaussian prototype demonstrated effective automation across multiple subsystems, crucial for livestock management. Its modular design allows seamless integration of feeding, watering, lighting, cooling, and waste removal. Tests confirmed that the system, reliability, energy efficiency, and sustainability for small-scale farming operation of grid. The system also enhanced animal welfare, reducing labor, support sustainable agricultural practices, and for our recommendations for the future works, we will focus on the integration of real-time data logging, wireless communication for remote monitoring, and health sensor to track animal activity and detect anomalies, extended field trials in diverse agroecological zones with validate system robustness and scalability. Thank you very much.
And with that, we come to the end of our breakout session. For the last 3 days, we have been here. Thank you for the insightful researches that we have listened to. So many good ideas. I hope we will follow through and at least have some of them implemented. No questions. We are actually being waited. I ask that we cross over to Theater 4. Theater 3, yes. Okay, it's just across.